So your current assignment is to assess the equilibrium nature of a specific beach that you've been assigned, but also to then look at how we should manage that beach, particularly with respect to beach renourishment. So first we're going to take a look at how do you assess beach equilibrium. We're going to be using Google Earth to do that. So here we have a beach. You can see at the lower bit of the screen we have the elevation. So if we go inland from the ocean, it should be right around sea level, 0 meters in this case. And you go across the beach. The one thing that's nice about this beach, it's pretty wide. Now we like to focus on the dry beach because tide really matters. Sometimes dry beach is harder to tell, but in this case, this is the place where you can see the debris left by the waves. So this would be your typical dry beach right here. So you can measure your dry beach width. This part of the beach is just depends on the tidal range. But the most important thing, first of all, you need a beach that doesn't have a steep slope. We can go inland. You can see 1 meter, 5, 6, 7, 8, and then 4, 3. And so this is a dune. There is no steep slope, obviously. We never got much elevation. But the dune has variable slope, patches of open sand, patches of vegetation. This is a dune. So there is no steep slope. The second thing you need is you do need dunes, and this has dunes. This would be a typical view of a dune. And we can see the dunes extending along. Here's a blowout in a dune, but still, it's a nice, it's not a steep elevation. A wave can run right up into this area. Third, you can't have too much development or a steep slope that would block migration. We want a wave to be able to wash right over the beach system if it's a really big wave and use its energy in doing so. And the fourth is we can't have any break in the longshore transport. In other words, waves come in at an angle, they wash sand up, and it goes down, up, down, up, down. And so sand is being driven along the beach in that fashion. So the only thing that breaks it is either a barrier or deep water, and we don't see either of those in this case. So this is a good example of an equilibrium beach. Now we're going to take a look at some other beaches, and we'll get a sense of what else we can look at. So in this case, we're coming down to Crane Beach. Similarly, again, you see sand dunes. See how the scattered vegetation and sand, no real high elevations in here. You know, it's a couple meters high. Out here, you see the beach itself. You got an offshore sandbar at low tide. This would be your dry beach width in this case. And of course, you have no abrupt slope change. So we have to be able to migrate inland. With rising sea level, of course, your beach will just disappear. So in this case, there is no barrier. Waves can just wash right over the beach and dump sand inland here. There's nothing preventing that. If we're looking again at beach width, you want to look at the dry beach width. Here's the dry beach. There's the wave line. You can just measure how wide it is. You get your ruler tool right here. So different, and just be consistent. You can measure right to the edge of the vegetation, or maybe this is a nice line. It'll be easy to pick out. So I can pick out that's 150 feet. Here's your historic imagery. I can go back in time and see how has this changed. Let's drag our time back to 2007. And we see that that line is fairly similar. But now there is no dry beach out here. So the actual dry beach width is only right there. So things change with time. And so you can measure that using that historic feature in our ruler. Now, what happens if your beach is not in equilibrium? Let's look at some examples. In this case, we see a beach that has obviously a seawall along it right here. The beach is obviously really narrow. There isn't much of a dry beach. There's no dunes. But a seawall enhances wave energy, so all along here, the seawall prevents this from being in equilibrium. Too much, this is Nantasket Beach. And if you go up a bit, we'll see there's a lot of development here. Too much development, the beach really can't migrate inland. You'll see they pretend like these are dunes, but they're too narrow. They don't look like real dunes in the beach itself. And their slope, there's really not much of an elevation change to these houses, 3 meters. So this is not an equilibrium beach along here. Now, a lot of people get confused with bluffs versus dunes. So let's take an example of what's the difference between a bluff and a dune. A dune has a gentle slope. And a bluff is, you know, in this case, this is on Nantucket. We can zoom in on this bluff, tilt our view a little bit. what you'll see is this huge steep hill here. Our elevation down here, 2 meters, go up to the top of the bluff. We're at 30 meters. So we have 28 meter, 90-foot high bluff right here. So wave comes in, it hits the bottom of the bluff, can't climb over it, crashes against it, takes the sand back offshore. That's why there's no vegetation here. This is an erosive feature, with sand being eroded at the bottom and hence sand in the top eroding because it's a fixed slope. So this is a bluff, not a dune. It's nice and sandy, so the beach is going to get replenished with sand from it. But there is no... So now we go further up, and again we'll see, take a look at this beach. There's no dunes. We have a beach here, here's the dry beach, and then we got houses. You look along this beach, there's too much development, no dunes, so it's definitely not in equilibrium. And you get down to the southern end and you have a seawall built right along here. So we have lots of examples. You can also take a look at, what if you have groins along the shore or a jetty? These are groins features. They block longshore transport. Sand wants to get carried along the beach. They interrupt it, so that makes your beach not in equilibrium. These groins, they just have sand on either side. They don't do anything else. They're generally illegal because they do lead to beach erosion. A jetty is where you have the same type of thing, but now you have a shipping boating channel, and so you really need a jetty to keep this open. Otherwise, sand carried along the slump by longshore transport would have filled this in. So this is a longshore transport interruption, which means your beach is not in equilibrium. So you can look at your beach through time and see how it's changed. You use the historic imagery. We're back in 2007. We can go ahead to 2014 in this case and see how the beach has changed to decide how it's doing. Now for your beach, given, is it in equilibrium? How has it changed? Now let's take a look. You go to your particular beach, and this is the beach renourishment viewer. I'm going to choose my state of Texas, and we'll look at a specific beach in Texas. And we'll just give it a second to open it up. And as soon as it's loaded, you'll be able to select a specific beach in Texas, and then we'll get our information. So each of you has been assigned a beach, so you'll be able to go ahead and do that. So this is a beach nourishment viewer, and so we'll just pick this particular beach right here. It tells me it's had 6 episodes of renourishment. Here's the volume. Here's the cost. You might as well use $2,013. There may have been more renourishment, particularly recent ones. This hasn't been updated necessarily to reflect the most recent ones, but you have to just use this data, just trust this data. And based on the fact that they needed 6 of them, you'll have to assume that they didn't last very well. If you want more information, you can get more here, and it'll give you, you'll sort by date as the graph it's going to give me, so that'll tell me when those are. And that will help me decide, is beach renourishment a good answer for this particular beach? So you'll see they are only showing one of them, the cost here. So that's why the cost is low. But they had other renourishment, so it was almost an annual deal here. So that's all you need from here is for your beach. How much beach renourishment? Is it succeeding? In this case, it hasn't been succeeding because the beach, if you look at this beach, isn't doing well at all. So now let's go back to Google Earth. So let's say you want to use this snapshot of Google Earth to put into your PowerPoint. You just take File, Save, Image, and that'll save your image, and then you can just insert it into your PowerPoint and annotate that to PowerPoint to reflect using insert shapes and such. And then I want to keep the same view. So 348 meters is a nice clear shot. I can go back in time, and I can use other shots to show how this beach has changed, and that will decide whether or not you really think beach renourishment is going to help or not. You can see how much wider this beach was in 1995, and that the beach has gotten a lot narrower up to 2013. So that's how you assess beach equilibrium, and then beach renourishment to decide what's the best management practice for your particular beach.